Right, for the next few problems we're going to divide polynomials. So problem 10 is 5x squared minus 6x minus 8 divided by x minus 2. And I'm just going to factor this. I know that something times something equals a times c, which is negative 40. And that same something plus something is going to equal my middle term of negative 6. And so if I think about the various factors of negative 40 and which of those factors will also add up to negative 6, I'm thinking that a negative 10 times a 4 is going to equal negative 40, and a negative 10 plus a 4 will equal negative 6. So I've split my middle term, and I'm going to rewrite this keeping my end terms the same. So 5x squared minus 10x plus 4x minus 8. And I'm going to group that. So this equals this. Let's not forget about that, but I'm setting it aside at the moment. And if I group this like that, I can take out a common factor here, which will be 5 and x. And I'm left with an x minus 2. And then my common term, greatest common term here, greatest common factor will be 4. So x minus 2. Now I've got two new terms, this term and this term. The greatest common factor of these two terms is x minus 2, so I will factor that out. And then I'm left with this, 5x plus 4. So there, I have now factored this, and this is what I've gotten, and I'm going to divide it by x minus 2. And the numerator and denominator cancel each other out, so I can say that what we get is 5x plus 4. I put these arrows there because really this doesn't equal this, it only equals this. So I'm working, and then what we get is all of this equaling all of that, and that boils down to this. Done with 10. All right, 11. We've got another division problem. So we have 2x to the third minus 7x squared. Is that a minus or a plus? My eyes are getting tired. I can't read my own writing. I believe that's a plus 9x minus 4, and we're dividing it by 2x minus 1. And we could use long or synthetic division here. I think I'm going to go ahead and use long division. So I'm going to put this out here as my divisor. I am dividing 2x to the third minus 7x squared. Man, I'm doing a bad job of writing. Plus 9x minus 4. So 2x goes into 2x cubed, x squared times. So x squared times 2x is going to be 2x cubed, and then x squared times minus 1 is going to be minus x squared. I'm subtracting that because that's how we do long division, right? And these cancel each other out, and I will get a negative 6x squared plus, bring down my 9x. So 2x times something equals negative 6x squared. I think 3x will do that for us. Negative 3x squared times 2x is going to be negative 6x squared. Negative 3x times negative 1 is going to be positive 3x. So subtracting that. So 9x minus 3x is going to leave us with 6x. Negative 6x minus negative 6x is the same thing, so they cancel each other out. And I'll bring down my negative 4. Again, 2x goes into 6x 3 times. So 3 times 2x is 6x, and 3 times negative 1 is negative 3. And I'm subtracting that. So I'm going to end up with 1. What that looks like, this is a remainder. What this is going to look like then is x squared minus 3x plus 3 plus 1 over this 2x minus 1. And we're done. On to problem 12. For this one, we're asked to use synthetic substitution. And the problem is x to the 4th plus 3x to the 3rd minus x squared plus 2x minus 6 for x equaling 3. Now, you could just sub in 3 for every x everywhere, and you would get 153. So, knowing that, you could check to make sure that you did the synthetic substitution correctly, but we know it's really going to end up being 153. So we'll just sort of set that aside, keep that in mind. So synthetic division, here we go. My x is going to equal 3. I'm putting that in my little box in the corner, bringing my coefficients down. So I've got a 1, 3, negative 1, 2, and negative 6 for my coefficients. Bringing the 1 down here. 3 times 1 is 3. Add these together, I get 6. 3 times 6 is 18. Add these together, and I get 17. 3 times 17 is 51. Add these together, and I get 53. 3 times 53 is 159. Add these together, and I wind up with 153, and that's the solution for a synthetic substitution. All right.